Magma oceans, supersonic winds, scorching hot days, and instead of rain, a bunch of rocks falling on your head. Just another one of those days, huh? Astronomers recently discovered a new superplanet out there. K2 414b is an exoplanet that's around 200 light-years away and in serious need of a new name. An exoplanet is just a fancy way of saying that a planet orbits its own star in another solar system. The Earth orbits the Sun, so this planet has its own orbit party going on. So what makes K2, bunch of numbers, so scary? Picture our beautiful little blue planet Earth. Now imagine that all the volcanoes in the world suddenly erupted at the same time and lava covered the oceans and seas. Fiery hurricanes, thousands of times faster than normal, blow all over the place, 24/7. And it starts raining rocks every now and again. Rocks, like on your head. Thankfully, not in your head. This scary planet came into our lives about 2 years ago. Scientists are still studying it. So, what's a typical day like? For starters, you can forget about breathing. Oxygen decided to take a pass on this planet. You'd have to get used to sodium, silicon monoxide, and silicon dioxide, which is, as you guessed, not great. And that's just scratching the surface. Who knows what other chemicals are lying around? And yes, magma oceans. The planet's surface is covered in molten magma as far as the eye can see. This lava planet orbits really close to its star, which is why the surface is like a fireplace. The closest planets to our Sun are Mercury and Venus, but this planet's even closer. And what's even more weird is that half the planet is in constant daytime, the other half night. It's tidal locked, just like our moon is. No matter how long you stare at it, you'll never see the other side. That's why the all-day, everyday scorching fiery side is so hot and overflowing with magma oceans, while the other side's in a constant state of deep freeze. If the magma doesn't burn you, you've still got big problems, and please don't look up, it's raining rocks. On Earth, water turns to steam, rises up, becomes clouds, cools, and falls as rain. Over there, on planet Fireball, it's exactly the same, except for it's rocks, people. The planet's so hot, it vaporizes rocks. Oh, and don't forget the supersonic winds with speeds up to 3,000 miles per hour. Imagine your hat getting blown off your head at 5 times faster than an airplane. The strongest wind on Earth was the tropical cyclone Olivia that hit Australia. It was blowing at 250 miles per hour. Now imagine 12 times that. On the sunny side of the planet, you're looking at a roasting 5,000 degrees. The hottest it ever got on Earth's surface was in California, 135 degrees. It's pretty common for it to get near that temperature in the Sahara Desert, but that kind of heat's not exactly enough to make rocks evaporate. If you grew up near a desert, you already know how dry and hot it always is. But did you know that deserts can reach freezing temperatures? A desert, by definition, is a large area with little or no rainfall. That means no water vapor to keep the temperatures from going insane. In the daytime, the sun heats up the desert like an oven. But when the sun sets, the heat packs up and heads home, and it can get really cold. Some deserts have even reached minus 40 degrees at night. But wait, shouldn't deserts have snow if it's that cold? Well, some deserts have had a bit of snow here and there, but because there's no water vapor, there can't be that much snow. Just dry, freezing, sandy Sahara nights. Now, the Sahara Desert's actually not the largest desert on Earth. It's Antarctica. 5 million square miles of icy dryness, almost no people, and a whole bunch of cute penguins. Penguins technically live in a desert. Back to the Fireball planet, this time the night side. Never-ending darkness and extreme cold, about minus 330 degrees. Add in some supersonic winds? Earth's coldest? Minus 130 degrees at a research center in Antarctica. So, how does this jalapeno pepper exoplanet stack up against some of our neighbors? Well, Mars isn't exactly livable either. It's the red planet, so you'd think it'd be hot most of the time. But it's usually freezing, well, way below freezing. And if you're planning a weekend getaway to Mars, you can leave the umbrella at home. Nah, it doesn't rain rocks, and it actually hasn't rained there for millions of years. At least Mars has days and nights, and it's like Earth in other ways. Mars' equator is steamy hot, and it gets pretty cold at the north and south poles, just like Earth. Scientists even discovered old bits of carbon dioxide snow there. The entire planet is actually covered in carbon dioxide, with a splash of nitrogen here and there. Scientists even reported intense snowstorms on Mars, but because it's mostly carbon dioxide, it's not your typical snowstorm. It's more like a dry ice storm. That's the stuff they use in fog machines. Mars isn't the only place where climates are going cuckoo. Jupiter's famous for its gigantic storms. Not like the ones we know on Earth. I'm talking about storms that last for centuries. The Great Red Spot on Jupiter is actually a 400-year-old storm, and you could fit 4 whole Earths inside of it. So it's been around for a while, but it's nowhere near as intense as the storms on K2. Venus also has intense rain, but it's not made of rocks. It's sort of worse. It rains sulfuric acid. That stuff can give you severe skin burns and rip nasty holes through your umbrella. Venus's atmosphere is filled with carbon dioxide, which acts like a net to trap in the sun's radiation, and it's insanely hot. No magma oceans, though. Mercury is the closest planet to the sun and doesn't even have an atmosphere. That means no storms, clouds, rain, wind, whatever. Mercury is kind of like a desert here on Earth. No water vapor and no rainfall. That means temperatures shoot up during the day and drop like crazy at night. The K2 exoplanets, like the most extreme parts of all of our solar system, all rolled into one scary planet. But we're not headed there anytime soon. We haven't even been to Mars yet. That's all way off in the future, and 200 light-years is a really long travel time. If we're going to move anywhere anytime soon, we'll probably want to set up camp on the moon. No magma oceans, no warp speed winds, nice temperatures. So, where would we even start? Well, the main issue is that drones and remote control robots are getting more and more advanced. It's way cheaper to send them over to map out the moon for us while we're safe here on Earth. And if we ever want to begin space exploration for real, we'd need a proper space base. And what better place than our little shiny moon? So, why do we even study those far-off planets? What's the point? Well, planets are like people. They're all different ages and live in all different places. The more of them we study, the more we can understand why there's life, aka us, on Earth and not on any other planet so far. When we see crazy new planets, we get crazy new ideas, which can turn into awesome inventions that make our lives easier. Even just going into space gives us new ideas. Scratch-proof lenses, some firefighting equipment, water filtration systems, wireless headsets, invisible braces, that tiny vacuum you use to clean those crumbs in from between your couch cushions, they were all invented to help astronauts work better in space. And now they make our lives better every day. Maybe we'll figure out a new energy source someday, thanks to a far-off planet or star. Or we might discover a new compound that will make our buildings stronger or more energy efficient. Okay, here you are in the middle of the ocean. It's endless, but you can't see it because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans. Its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%. Exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, The 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface, but if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214, an unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but two at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the Sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? Alright, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves. Earth. The third rock from the Sun. The blue planet. You get it. Its atmosphere is made up of around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide. A nice balance for any living creatures to breathe. The weather here is also perfect for life to exist, unlike places like Saturn, Mercury, or any other celestial object in our solar system. We have the troposphere to thank for that. It's the densest part of the atmosphere on our planet and is 5 to 9 miles wide. It's the layer of the atmosphere that always affects our weather and secures the right conditions for life to exist and to have bodies of water. Earth is just sitting in its orbital path, minding its own business, revolving around the Sun until, BAM! Venus and Mars swoop in and spoil the fun. No one wants to leave poor Earth alone. These two relatively large celestial objects moving toward Earth will have dire consequences for our planet, starting with changes in its orbiting trajectory path. The planet's orbits in the solar system have to maintain the right balance so that nothing goes haywire. Of course, if any large object approaches Earth, it would throw our orbiting path off course. The planets will revolve around each other, which will cause plenty of natural disasters on our lands. This will also affect our rotation timing, potentially slowing it down. Days will not flow but drag by. Animals that rely on daytime will need to readjust their biological clocks. Nocturnal animals will also need to figure out how to cope with the long nights. Humans have adjusted pretty well to the 24 hours a day timing. Time itself is just a human construct to measure things. We'll have a tough time sleeping and adjusting to the stretched day. Marine animals rely on the natural current flow to migrate around the oceans. With Mars and Venus crashing the party, it looks like they will also need to find new paths. Birds migrating to other lands throughout the year will also be confused and not know what to do. In general, the Earth's temperature will rise, and massive heat waves and permanent climate changes will occur. This brings us to our next issue, the heat. The radical temperature rise will turn everything into a barren desert. It'll be summer all year long, especially if Venus is in the picture. most of the planet will dry up and won't be suitable for growing crops. Venus is hot, I mean really hot. Even though it's not the closest planet to the Sun, it's still the hottest. The temperatures on Venus are close to 900 degrees Fahrenheit, which will melt you like an ice cube. The lands on Venus are generally flat, probably due to the temperatures. It's mainly hot because its atmosphere is thick and traps the hazardous gases inside. If Venus inches its way towards us, it'll invite those gases to our atmosphere and compromise it. Mars, or the red planet as we know it, is very cold. That might stay the same if it starts rotating around us. It's also home to the largest dormant volcano in our solar system, which makes Mount Everest look like a tiny bush compared to a tree. With so much instability, it might just wake up one day and spew out molten lava. Mars has a very thin atmosphere, which makes the planet chilly. Its gravity is quite similar to ours. It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and sunset. The three planets orbiting each other will eventually collide. It's just a matter of time. And the Moon, just hanging out like a fly on the wall, will be so insignificant that something will eventually throw it off course and another planet will capture it to its orbit. Or, in the most dire case, it will collide with one of the two intruding planets. Earth will experience extreme tidal waves like nothing before. The two new planets revolving around Earth will cause a major imbalance, making our gravity shift out of control. Each tidal wave will be bigger than the previous one and will cover the dry land. Plenty of little scattered islands in the oceans will be completely submerged. Coastal cities and towns will also be home to fish. Flat countries in general will need boats to get around. Dams and dikes won't be enough to stop the water from coming in. Everyone needs to move towards higher ground to escape the floods. With the climate getting hotter, the polar caps will melt like ice cream on a sweltering summer day and add to the water level rising. Within a few months, the whole Arctic will be nothing but liquid. But wait, there's more! The crust will wear out due to the instability of the Earth's surface and fluctuating gravity. The Earth's crust is mainly made up of oxygen, which means we're basically walking on air. We might experience more earthquakes than before, and dormant volcanoes will wake up from their deep slumber. The skies will be covered in ash, making flights impossible. No one can travel by sea or by air. Importing and exporting will become history. The overall climate will get hotter, just like in Venus. The three planets orbiting each other and their huge mass might even unintentionally welcome other planets and celestial bodies to join the party. So, what if Jupiter decided to turn up? Now, Jupiter is the largest planet in our solar system. To give you an idea, the Earth would be just the size of a grape if Jupiter were the size of a basketball. It also has the largest storm we can perceive. That's known as the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. Now, by the time you're done watching this video, you can expect the storm to still be going at it. Since the planet is huge, gravity must be quite strong here. It also has many moons, some of them of our little Earth. There will be no room for any proper space among the planets. Jupiter's moons will be thrown off course and latch onto other planets around. Some of the moons might collide with each other, causing massive debris to be displaced all over the place. The gravity of the planetary party will attract comets to enter the atmosphere, potentially crashing down on us. Oxygen levels will deplete, so the Earth's crust crumbling will continue. It'll rip open the ozone layer, causing heavy strokes of ultraviolet waves to enter our atmosphere. We won't be able to step outside for too long without some protective gear and oxygen tanks. Human civilization will change drastically. We'll all live in sheltered containers that will provide clean air and safe and filtered sun rays. The shelters will be sturdy enough to withstand frequent earthquakes. We will grow only enough crops to sustain ourselves until we leave the Earth. Since it'll only be a matter of time before the planets collide, the next step would be to create large rocket ships to fly us out of the Earth. With Mars, Venus, and Jupiter revolving close to us, it won't be easy to do so. all the space debris will be blocking us from exiting the space zone area. The only safe place outside this region will be many millions of miles away, where only single planets exist. They may or may not have the conditions to host life, but humans will have the technology to land just about anywhere with similar gravity and construct the right shelters. Eventually, Mars, Venus, Earth, and Jupiter will collide with each other and break like eggs, like a big space omelet. Don't forget the moon's crashing and breaking in the mix, but we'll already be far, far away by then, hopefully. Extremely hot and insanely fast. Yeah, that's me. Oh wait, you mean the space thing. Okay, first, they discovered Peg 51, an exoplanet that orbits a star similar to ours. An exoplanet is any planet outside of our solar system that orbits a star that's not the Sun. This planet was completely different from anything we've ever found. Almost the same diameter as Jupiter, but half the gas giant's mass. It took only 4 days for this exoplanet to orbit its star, which seemed impossible. It was definitely too fast for something so massive. And then, scientists started finding something they've named hot Jupiters all over space. Lots of heated gas giants were located only a couple of million miles away from their stars. Sometimes, there were a couple of space bodies orbiting their stars pretty closely, and many were a few times bigger than Earth. Solar systems where they found hot Jupiters are not like ours. We have a neat system with smaller rocky planets on the inside and big gas giants on the outside. And almost all of them peacefully orbit the Sun, following their trajectories. Everything is in order. When a star is at the earliest stage of its formation, it creates a disk of gases, debris, and dust surrounding it. It's called an accretion disk. These gases slowly get pulled into the star because of its gravitational forces, and this leads to some kind of a stellar whirlpool. The outer parts of the disk are more gas-dense than the center. With time, the whirlpool effect gets even stronger. The same thing happens with hot Jupiters, which causes these gas giants to start orbiting much faster than usual. This also carries it further toward the star in a tightening spiral. Luckily, our Jupiter didn't become a hot Jupiter. Our gas giant started its life as an icy Earth-sized asteroid, which is different from the way hot Jupiters form. During the time when it was forming, Jupiter was around 4 times as far from the Sun as it is today, somewhere between Uranus and Neptune. About 2 to 3 million years after Jupiter first formed in the accretion disk of our Sun, it started a 700 million year long phase astronomers call the Grand Tack. Now, tack is something a boat performs when going towards a buoy and then slipping past and around it. Then it speeds up and goes in the direction where it came from. That was the same thing Jupiter started doing, and in its tightening orbital migrations, the planet's gravity could have moved many asteroids and other space bodies, distorted the orbits of larger planets, and caused collisions and chaos. Jupiter's grand tack would have destroyed many big space bodies. It's a could-have-been scenario, but luckily, Jupiter changed its course and became a peaceful gas giant. Neptune, Uranus, and Saturn were starting their own version of this chaotic process. Saturn even got so big that its gravity started pulling Jupiter away from its orbit. But after some time, these gas giants' orbits became locked. Then both of them managed to clear away the gases remaining between them. And since these gases were some sort of fuel for the planet's migrations, Jupiter and Saturn could both finally settle into the stable orbits we know today. Jupiter can still lob 1 to 2 icy asteroids at the inner planets from time to time. But when our planet was younger, this could have been one of the processes that formed the oceans on Earth. But Jupiter is much calmer these days. Saturn's gravitational forces have moderated the situation and are now keeping it under control. Now, Jupiter is our protector. It's 2.5 times the mass of the other planets of our solar system combined. It's some sort of a gravitational shield orbiting around the inner part of the solar system. Jupiter redirects incoming debris and asteroids away from the inner planets, Mercury, Venus, Earth, and Mars, keeping us all safe. Because of this, Earth has always been protected, so our planet has had enough time to evolve complex life forms. and it hasn't been destroyed by asteroids, hot Jupiters, or other space bodies. Jupiter wasn't the only planet that could have collided with Earth. Scientists think Mercury might have been involved in a hit-and-run accident with our planet. Mercury is the innermost planet in our solar system. It's the closest to the Sun and the smallest planet out there. And it also keeps getting smaller. Nowadays, its diameter is around 9 miles smaller compared to its size 4 billion years ago. Scientists think this might be happening because the planet's core is made of iron, and this iron is cooling and becoming solid, which is slowly reducing the planet's size. Mercury is the planet with the biggest number of craters in our solar system. Its atmosphere is really thin, so it can do nothing to keep the planet protected from meteors. The largest crater on Mercury's surface is at least 963 miles across. It could fit Western Europe from Germany to Portugal. The object that formed such a crater must have been at least 62 miles long. With all these craters, Mercury looks similar to our Moon. It orbits the Sun faster than the other planets, so 1 year on Mercury lasts around 88 Earth days. That means celebrating a birthday every 3 months or even more often. At the same time, the planet rotates so slowly that a day on Mercury lasts almost 59 Earth days, a long time to wait to go to bed. There's a piece of Mercury on our planet. In 2012, a green meteorite was found at a street market in Morocco. Scientists studied its composition and concluded it could be from Mercury. Mercury doesn't have its own moons because of its small size and weak gravity. Plus, the planet is too close to the Sun. By the way, the only other planet without moons in our solar system is Venus. Mercury has a really thin crust, like a good pizza. One of the theories of the planet's formation claims there was a major collision where the planet lost most of its crust. It could have also moved Mercury from its original spot. It wouldn't be unusual. The gas giants in our solar system also didn't form in the location where they are today. Mercury also has an eccentric orbit, which means it could have been kicked out of its old orbit and moved to a new one. Scientists also think Mercury might have collided with the early Earth. One theory says that's how the Moon could be formed, out of all the material flying away after the big crash. There might even have been pieces of Mercury's crust in the mix. Exoplanets Kepler-107b and Kepler-107c are a pair of planets that orbit a star similar to our Sun in the Kepler-107 system. It's around 1,700 light-years away from us. These planets have almost identical sizes, both with a radius 1.5 times that of Earth. But one of them, Kepler-107c, is almost 3 times as dense as the other. That's because the planets have a different composition. Some scientists believe that Kepler-107b is less dense because it probably collided with another unknown planet in the past. This powerful hit took away part of its surface and left behind a very dense core rich in iron. A huge comet hit Neptune around 200 years ago, but since Neptune isn't a rocky planet with a thin atmosphere like Mars or Mercury, it's harder to find evidence of this impact. But a comet called Shoemaker-Levy 9 broke apart in 1994 and smashed into Jupiter. Astronomers managed to record this event. It helped them learn more about the elements and molecules the collisions left in Jupiter's atmosphere. This information helps scientists realize that the amount of carbon monoxide in the upper layers of Neptune's atmosphere is higher than in the lower ones. This means a big comet likely hit the planet in the past, since comets have carbon monoxide in their icy tails. Something huge slammed into Uranus, too, changing the planet forever. A space object twice bigger than Earth hit the ice giant. This left the planet tilted, and it looks as if it's rotating on its side. Uranus is extremely cold, way colder than it's supposed to be. It might mean that the object that slammed into it was probably a young protoplanet made up of ice and rocks. Also, some of the debris from that collision may have created a thin shell around Uranus. It still traps the heat coming from the core of the planet. There are strange energy pulses bombarding our entire galaxy, and they come from the other side of the universe. Over the last decade, scientists have been observing bizarre flashes of light coming toward our planet. This phenomenon is called fast radio bursts, or FRBs. These signals travel through a couple of billion light-years of dust and gas. That's a rather long way. So far, no one has figured out what's going on behind these bursts. Bang! Another hit on Jupiter. Let's see. Gas giant, the largest planet in the solar system, 318 times bigger than the Earth, 2.5 times bigger than the rest of the planets in the solar system put together. One more interesting thing. If it got any bigger, it would actually become smaller. You see, with more mass, the planet would be denser. That would cause Jupiter to start pulling in on itself. Scientists say Jupiter could have 4 times greater mass, but still keep the same size. It takes 10 hours to make a full rotation on its axis. It's the fastest spinning planet in our solar system and gets hit by so many space objects all the time. This was discovered by amateur astronomers observing Jupiter and saw some unusual flash at the planet's surface. Impact events cause flashes like that, and for some reason, Jupiter gets more impacts than other planets. In 1994, astronomers discovered Shoemaker-Levy 9, a comet that broke apart and collided with the gas giant. The original comet was approximately the size of one that erased the dinosaurs. However, this asteroid fell apart into more than 20 fragments. They darkened the planet's surface, and it remained like that for months. 15 years later, in 2009, astronomers saw a black spot on Jupiter, the size of Earth. It was the result of an asteroid around 650 to 1,650 feet in length. The biggest asteroid recorded on Earth hit the area of Tunguska, Russia in 1908. This caused a massive explosion, even though no one ever found a crater. So, why is Jupiter the target for so many space objects? Asteroids and comets that pass by Earth and Jupiter go almost at the same speed. The number density of the space object that may interact is almost the same too. But the cross-section of what they might hit is very different. Jupiter has 11 times the diameter of our planet, which means it has around 125 times the cross-section. The more massive some planet is, the stronger its gravitational attraction. So, it will entice some space objects drifting by. Our gravitational field is weaker than Jupiter's. If some object passes near us moving at a speed of 22,300 miles per hour or less, our gravitation will attract it. Asteroids and comets usually move at bigger speeds. Jupiter attracts most of the comets and asteroids passing by. If our planet was hit by such big objects as frequently as Jupiter, we'd have extinction like with dinosaurs thousands of times more often. In 2020, scientists found there was an unusual asteroid in the orbit of Venus, the first one there. The size of a small mountain and rich in minerals we can find in Earth's deep rocks. They even think it could be a clue to a bigger set of asteroids created when our solar system was forming. That's not the only mystery around Venus. The planet has insanely violent winds that drive clouds and storms around the planet at speeds greater than 220 miles per hour. That's 60 times faster than Venus itself rotates. Also, scientists are still not sure what happened with its oceans. They believe since the planet is so close to the Sun, the water evaporated and went into the atmosphere as steam. It trapped heat coming from the Sun, heat that would have vaporized more and more water over time. Venus probably had an environment like on Earth, but a very long time ago. The theory says many comets and asteroids were slamming into Venus. Billions of the planet's pieces were flying all around. Some may have even crashed into Earth's moon. Pieces that slammed into our planet are probably buried very deep, since we have greater geological activity than the moon. Uranus also had a collision, but a more serious one than asteroids. The rest of the planets in our solar system mostly have an axis of rotation that kind of points up from the elliptical plane. Uranus is tilted, lying on the side, so a season there lasts 42 years, when either its south or the north pole is pointed at the sun. Most of the planets also rotate counterclockwise when you see them from above our solar system. Venus does the opposite, which means maybe it was kicked off axis a long time ago. Uranus may have collided with the other space body millions of years ago. When our solar system was still very young, the orbital configuration of Saturn and Jupiter may have crossed. Their gravitational forces kind of created orbital momentum and transferred it to Uranus. That knocked it off axis. Millions of asteroids orbit the Sun, and not so many pass by Earth from time to time, so we don't have some dangerous space bodies coming toward us. The plan is to visit Mars in the 2030s, and scientists hope Mars won't be a target of some bigger space bodies. New craters are formed on the red planet every 1 to 2 days. They can be 13 feet across, which means they could have been formed by objects that are the size of a soccer ball. Since the atmosphere there is thinner than ours, smaller bodies can enter easier. Most of the Martian north is smooth lowlands. The south is higher, full of craters, and the planet's interior has a surprising amount of rare metals. The theory says this is because a big celestial body collided with Mars and tore away a part of its northern half. Debris from that asteroid circled the planet and then mixed into two small moons that orbit Mars. We also have some Mars rocks on Earth, found in the Sahara Desert, Antarctica, and some other places across the globe. Some of these rocks have gas that's chemically the same as the atmosphere on Mars. Rocks probably came due to a big explosion that happened when some larger asteroid or meteor that was ejected from Mars and landed on our planet. Mercury also has a thin atmosphere, so there are many smaller strikes there. Imagine waking up, going to your window, and see there are micrometeor showers every morning, which is something that happens on Mercury. This strange weather pattern shapes its atmosphere, called an exosphere. Mercury is so dense, its heavy iron core accounts for 2/3 of its total mass. Scientists think it could have been bigger in the past, but many collisions got the surface sort of scraped off. It's been constantly bombarded by rocks from space that left marks with craters. Plains on its surface seem to have been created because of volcanic lava spilling over the surface and then dried smooth. Many craters are filled with such a material, which means there's one more thing that rocked Mercury's world: volcanoes. There's an unusual group of asteroids discovered near Neptune. Wide range in sizes, from big metropolitan areas to tiny pebbles. They are thought to come from an asteroid group called the Kuiper Belt. It makes a ring well beyond Neptune. But these new asteroids have different colors than the Kuiper Belt. They're so far away from the Sun, their surface was supposed to stay almost pristine, but they have a similar color to those sun-baked asteroids around Jupiter. Like the rest of the planets, Neptune gets heat from the Sun. But there's something mysterious inside the planet that makes it generate more heat than it gets. This affects its weather, and Neptune has the weirdest weather in the whole solar system. Massive storms, insanely high winds, cirrus-like clouds that rapidly change all the time. There are dark spots in its atmosphere. They come and go. We receive 1,000 times more sunlight than Neptune. Gas giants like Saturn and Jupiter can protect our planet from asteroids. Without them, the big impacts that created enough debris to form both moons and other planets would happen more often. There's a huge asteroid going around Saturn, which could be a potential flyby by 2031, more than 10 times bigger than the asteroid that erased the dinosaurs. Titan, one of the moons orbiting Saturn, 80% more massive than our moon, is actually the only moon in our solar system that has an atmosphere. It's 1.5 times thicker than ours and consists mainly of nitrogen, like our atmosphere. No one knows where all that nitrogen came from. However, unlike Saturn and most of the other places in our solar system, its moon has a real potential to host life.
How do people usually describe planets? Massive, freezing, boiling hot, seismically active. Let's admit it, shiny is not normally on the list. Unless we're talking about a world called LTT 9779b, which might be the shiniest planet we've ever seen. This exoplanet, which is basically any planet outside our solar system, is ultra hot and acts like a giant space mirror because it's covered with a thick layer of reflective metallic clouds. This unusual world is located about 264 light-years away from our planet. And the most amazing thing about it is that it reflects approximately 80% of all the light its parent star sends its way. For comparison, Earth reflects a mere 30% of the light it gets from the Sun. The bizarre exoplanet is even more reflective than the shiniest planet in the solar system, Venus, which reflects around 75% of sunlight due to its thick clouds. LTT 9779b is 5 times as large as Earth, which makes it the largest space mirror ever discovered. By the way, this world was found by NASA's Transiting Exoplanet Survey satellite mission in 2020. But the highly reflective nature of the planet was uncovered later thanks to a follow-up investigation conducted by the European Space Agency exoplanet hunting spacecraft CHEOPS, which stands for Characterizing Exoplanet Satellite. Now, imagine a planet the size of our ice giant Neptune. It's a burning world floating close to its star. If you stepped on its surface and looked up, you'd see heavy clouds of metals floating over your head, raining down titanium droplets. The planet's size, coupled with its insane temperatures, allow astronomers to classify the planet as an ultra-hot Neptune. Now, a planet's high reflectivity is a quality known as albedo, and in the case of our shiny world, its albedo mystifies scientists. All because most planets that are not ice worlds, or planets with thick layers of reflective clouds like Venus, normally have low albedos. Their atmosphere or surfaces simply absorb the light coming from their stars, preventing it from getting reflected back into space. And initially, researchers were sure that LT 9779b would have a low albedo. After that, by no means was it an ice world. Not with the surface temperatures reaching 3,650 degrees Fahrenheit on the side of the planet permanently facing its parent star. It was supposed to be too hot for water clouds to form. Even clouds of metal or glass wouldn't be able to form in such a scorching climate. Astronomers expected a planet like that to have its atmosphere destroyed by its star, which would leave behind a lifeless, rocky world. That's why discovering metallic clouds was so unexpected. Of course, researchers were eager to find out how such clouds could have formed. It had remained a mystery until they decided to think about the cloud formation in the same way as condensation that appears in the bathroom after you take a hot shower. There are two ways to steam up your bathroom. You can cool the air until the water vapor condenses, or you can keep hot water running until clouds form. It will happen when the air in the bathroom becomes so saturated with vapor that it won't be able to hold it anymore. So, researchers came to the conclusion that most likely the atmosphere of the shiny planet became oversaturated with silicate at one point. And then, metal started vaporizing due to boiling hot temperatures on the permanent day side of the planet. But if you think that the reflective nature of LT 9779b is its only unusual feature, you might want to hear this. The exoplanet is an example of an extremely rare planetary type, and ultra-hot Neptune. Astronomers have been searching for such planets for decades, but those preferred to remain a mystery. The fact that the planet survived so close to its star might be linked to its high reflectivity. Some experts believe that the metal clouds covering the planet probably reflect light and prevent the planet from overheating and evaporating. Plus, such a highly metallic atmosphere is much heavier and harder to blow away than any other. Now, about 850 light-years away from Earth, a planet called WASP 121b orbits its star. This planet is a hot Jupiter, which means it's a gas giant moving very close to its star. And because of such a short distance, the planet is also insanely hot. The average day temperature there is around 5,000 degrees Fahrenheit. Interestingly, just like our previous shiny world, this planet also has metallic clouds floating over its surface. But that's not the only oddity. WASP 121b has a bizarre oblong shape. Can it be because the planet is tidally locked to its star? It means that one of its sides always faces the star, while the other is always turned to the darkness of the cosmos. In other words, it's always daytime on one side of the planet and nighttime on the other, which causes crazy temperature differences. Researchers think it might be the reason for the metallic clouds. The water cycle on WASP 121b is also pretty bizarre, to say the least. On the illuminated side, the atoms that make up the planet's water get ripped apart by the insane temperatures. After that, they get blown by winds moving at 11,000 miles per hour to the other side of the planet. There, much lower temperatures allow the atom to recombine into water molecules. At the same time, the nighttime side is cold enough for metal clouds consisting of iron and corundum to form. When these clouds migrate to the daytime side of the planet, they vaporize and rain down metal on the planet's surface. But if these clouds don't seem impressive enough, I've got more. Astronomers predict that the planet will rip itself apart in the next several million years because of its incredibly fast winds and wild temperatures. Plus, the gravitational pull of the planet's parent star also plays its role in this dark prediction. Since WASP 121b is so close to the star, the star's gravity pulls the planet into a weird oblong shape and makes gases like iron and magnesium leak from the planet's atmosphere. This pull is so strong that the planet is always on the verge of a tidal disruption. If it ever happens, the planet will come apart for good, metallic clouds and all. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists got some proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. Another planet you probably shouldn't set foot on is WASP 76b. There, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit larger than Jupiter in terms of size and is located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between the planet and its parent star is 10 times shorter than the distance between Mercury and the Sun.
Early Earth might have been purple, not green. There's a theory that ancient microbes used molecules other than chlorophyll to absorb sunlight. These molecules likely gave living organisms a violet tint. Scientists are almost sure that our planet once had 2 moons. One of them was a tiny thing, no larger than 750 miles across. Unfortunately, it crashed into the other moon, which is now Earth's only natural satellite. Until recently, there was one more object orbiting our planet. It was a temporary mini-moon called 2020 CD3. This tiny space rock, no bigger than 3 feet across, was pulled into our orbit more than a year ago. Astronomers believe the mini-moon left Earth's orbit in March. From 60 to 100 tons of space dust drift down to our planet's surface every day. These tiny cosmic particles are mostly released by comets, which are usually made of dust and ice. When the sun turns this ice into vapor, the remaining dust travels down to Earth. If you look at Earth from space, you'll see a blue ocean planet. Almost 70% of its surface is covered with water, and its average depth is 14,000 feet. But if you gathered all the water into a sphere, it would be a mere 870 miles across, just barely enough to cover Texas. and that's including all the water in the seas, oceans, rivers, lakes, ice caps, groundwater, and even those tiny droplets in the atmosphere. All Earth's air, yep, all 5,140 trillion tons of it, would make a slightly larger ball. By the way, the further away from the surface, the less dense the atmosphere is. That's why half of Earth's air is within the first 3 miles above the surface of the planet. Every 200,000 to 300,000 years, our planet goes through a magnetic pole reversal. It's not an instant process, though. It can last hundreds or even thousands of years. We live inside the sun. Its atmosphere stretches far beyond its visible surface. And even though Earth is 93 million miles away from the star, it's still within the reach of the sun's atmosphere. Auroras happen when charged particles from the sun get caught by Earth's magnetic field and crash into the upper atmosphere near the poles. The Hudson Bay of Canada is a gravitational anomaly. This area has lower gravity than any other place on Earth. You'd weigh less standing at the equator than at one of the planet's poles. Mars has only 15% of Earth's volume and less than 10% of its mass. And still, the red planet and Earth have almost the same landmass. It's because about 2/3 of our planet's surface is covered in water. The Pacific Ocean contains more than half of the world's free water. It's also by far the largest ocean. All Earth's continents could easily fit into the Pacific Basin. Our planet is gradually slowing down the speed of its rotation. It happens at an unhurried pace of 17 milliseconds per 100 years. Because of this, our days are becoming longer. And still, only after 140 million years, the day on Earth will last 25 hours. The ocean on Jupiter isn't made of water. It's filled with metallic hydrogen, and its depth is a staggering 25,000 miles. That's actually almost the same as the circumference of Earth. A year on Mercury is just 88 Earth days long. This planet also has an extremely squashed orbit. Its distance from the Sun varies from 28 to 43 million miles. Even when you're standing, sitting, or lying still, you're moving at more than 1,000 miles per hour. That's the speed at which our planet is spinning through space. At the same time, you'd be moving at this incredible pace only if you're at the equator. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, the atmosphere of Earth. It also has more than 20 layers. All of them are cold and condensed. Methane gas is a byproduct of natural processes, and this very gas is present in the Martian atmosphere, which confuses astronomers to no end. Mars produces around 270 tons of methane per year. Scientists can't figure out where the gas is coming from. Earth's southernmost continent, Antarctica, is only the 5th largest one, but it contains almost 70% of the planet's fresh water and 90% of the world's ice. Antarctica is also considered to be a desert. The inner regions of this continent get just 2 inches of precipitation a year, in the form of snow, of course. Mercury's surface is wrinkled. It happened when the planet's iron core cooled down and contracted. The wrinkles can reach a height of 1 mile and stretch for hundreds of miles. Lots of rocks on Earth have a Martian origin. Scientists analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places, and it turned out these rocks had arrived from the red planet. The only asteroid belt in the solar system astronomers know about lies between Mars and Jupiter. There are thousands of asteroids in this region, but they're extremely widely spaced. If you had to go through that area, the chances of colliding with an asteroid would be almost non-existent. The 4 largest asteroids, sometimes called minor planets, contain half the mass of the entire belt. And still, the total weight of all the asteroids there is a mere 4% of the Moon's weight. Mercury is the most cratered planet in the solar system. Its craters are named after famous musicians, artists, and writers. The valley called Valles Marineris on Mars is more than 10 times larger than Earth's Grand Canyon. The origin of this valley puzzles astronomers. After all, Mars isn't a planet known for its active plate tectonics. Atmospheric pressure on Venus is 92 times greater than that on Earth. Venus also has a much denser atmosphere. That's why only big meteorites can make it to the planet's surface. The smaller ones get slowed down and fall into pieces before reaching the ground. Our planet has its magnetic field thanks to scorching hot liquid metal that's flowing inside its outer core. This creates electric currents, and they, in turn, generate the magnetic field. For the past 200 years, the planet's magnetic north pole has moved northward for about 600 miles. These days, it's traveling faster than it used to, 40 miles per year versus 10 miles per year several decades ago. Volcanoes on Pluto, which are called cryovolcanoes, spit not lava, but ice. Instead of molten rock, they erupt water, methane, and ammonia. Jupiter's mass is twice greater than the mass of all the other planets in the solar system combined. Earth is the densest planet in the solar system, but this density varies depending on the planet's part. For example, the crust is less dense than the solid metallic core. Saturn's upper atmosphere is divided into layers of clouds. Those at the top are made of ammonia ice. Then, there are water ice clouds, and below them, layers of sulfur ice and cold hydrogen. Uranus rotates on its side. The reason for such an unusual position could be a powerful ancient collision, but so far, it's just a theory. By the way, Uranus is the only planet sitting on its side. Venus rotates in the opposite direction to the Sun. The reason might be a powerful collision with an asteroid or another space object. Iapetus, one of Saturn's moons, has an unusual coloring. It's two-toned. One of its sides is dark with a slight reddish hue, while the other is bright. Scientists haven't cracked this mystery yet. Jupiter's moon Io has hundreds of active volcanoes on its surface. It's the most volcanically active body in the entire solar system. The moon is covered in lava lakes and plains of liquid rock. Plumes of sulfur spew up for almost 200 miles. It takes light more than 4 hours to travel from the Sun to Neptune. Of all the planets of the solar system, Jupiter has the shortest day. It lasts for 9 hours and 55 minutes. Such a rapid rotation speed gives the planet its slightly flattened shape. Is it possible for a planet to have not one, not two, but many suns? Let's imagine what would happen to us if the Sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sunsets. Scientists even suggest that our Sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So they turned to the stars to find out what the reason might be. And then they assumed that it was a star that left our Sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's going to be a fun car trip, 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's gonna be as chaotic as can be. In stellar mechanics, it's called the 3-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how three stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who will have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe. So, they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Scholz bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, The length of a day will change, as well as the length of all seasons, and a year as a whole. They won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between two stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri B. That's a planet near the closest star system to our sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns. Tired of waiting for colonization? Does the Earth seem way too boring with all its problems and mosquitoes? Well, have no fear. It's time to take matters into your own hands and build your own planet. But before you start reaching for the cosmic glue and glitter, there are a few things you'll need to consider. Let's start our ultimate DIY project. First of all, we need to choose a location. Every planet has to orbit a star, right? In a cosmic buffet, every star has its own unique flavor. To keep things organized, astronomers use the so-called stellar classification system. The massive stars are the divas of the cosmos. They're huge, bright, and are always stealing the spotlight. But it's not all sunshine and rainbows. They have a short lifespan, burning out super fast, like a candle. They also have huge gravity, so be careful that your planet doesn't get sucked in. The dwarf stars, on the other hand, may be small, but they make up for it with their stamina. They can burn for trillions of years, which means that their planets have plenty of time to develop life. Super hot stars are blue or white ones, while the cold stars are usually red or orange. Yeah, seems like it should be the other way around, but we're not the ones making the rules. So what do we choose? Well, the planets around the blue and white stars could be scorched and fried, like a crispy chicken nugget. On the other hand, with cool red stars, our planet may turn into an ice ball. If that's your preference, then sure. But you can always pick a nice middle ground, a yellow star like our sun, for example. Not too cold, not too hot, but just right. Now that you've picked the star, let's start building the planet. The heart of the planet is its core. The core creates a magnetic field, an invisible force that protects a planet from harsh cosmic rays and charged particles. If it weren't for this field, the planet would be fried by the star's radiation, like a well-done burger. But the magnetic field isn't always a force for good. On some planets, like Jupiter, it's so strong that it creates super intense radiation belts and some crazy weather. If you were hoping to use a compass to find your way around on such a planet, forget it. The magnetic field would have the needle spinning like a breakdancer on caffeine. So, if you pick a small light core, the planet will have less protection from solar radiation, like tanning without sunscreen. On the other hand, larger cores can generate more heat, which can lead to more volcanic activity and earthquakes. The best option is a medium-sized core made mostly of iron and nickel. Enough to keep the bad things away, but not too strong to turn a planet into a cosmic hot potato. Once the heart is in place, we can move on to the next step. Ogres! planets are like onions. They have layers. Most planets have three main layers: the core, the crust, and the mantle. The core is the filling, as we've already discussed. The mantle is like a hot and gooey layer of caramel between the crust and the core. And the crust is like a thin layer of icing on a planetary cake, covering its surface. But not all planets are built the same way. Because of that, we have tons of options. First up, we have the gas giants, the big boys of the universe. In our solar system, it's Jupiter and Saturn. They don't have a crust at all. They're basically huge balls of gas, like hydrogen and helium, hence the name. Next, we have the ice giants, like Uranus and Neptune. They're like younger, cooler siblings of gas giants. These planets don't really have a solid surface, but it's not pure gas either. They're made mostly of water, ammonia, and methane ice. There are also ocean worlds, and no, they aren't made of pure water. They do have some kind of solid surface, but it's located so deep, and the ocean on their surface is so huge that it kinda does look like a giant water drop. Finally, we have terrestrial planets, like the Earth. They're made mostly of rock and metal. These planets have a surface to stand on, and usually come with a cool mineral collection. And let's not forget about the dwarf planets, the small but mighty. Pluto is probably the most famous one, but there are others in our solar system: Eris, Ceres, Haumea, and so on. They're the scrappy underdogs of the planetary world, always trying to prove their worth, but never making it to full-fledged planets. Which type do you like the most? Gas giants are probably the coolest ones with their enormous sizes, crazy winds, and scary lightning. We also need to create an atmosphere. It's the outer layer of a planet that plays a huge role in its climate and weather. It's also the planet's ultimate protector. Did you know that 90 to 95% of meteors burn up in the Earth's atmosphere? Imagine what would happen if they didn't. Dense and hazy atmospheres, the ones you'll find on places like Venus, have thick layers of carbon dioxide and sulfuric acid. In other words, it's not a planet, but an oven. It's so hot that you could cook a pizza on its surface in no time and get cooked yourself. Next, we have thin and wispy atmospheres, like on Mars. The thin layer of carbon dioxide makes its surface pressure about 1% that of Earth's. On planets like these, you could fly like a superhero if you had a good enough jetpack. Then we have mixed atmospheres, like the one on Earth. The layers of nitrogen, oxygen, and other gases create the perfect conditions for life as we know it. It's also where we get to enjoy sunny days, rainbows, and of course, water. And last but not least, exotic atmospheres. You'll find them on planets like Neptune, where the layers of hydrogen, helium, and methane create a blue-colored world that looks like a giant marble. They're super weird and unusual, so just perfect for creative planet builders. Almost done. The final question is, would you like your planet to have life on it? In that case, there are some things you should consider. For example, it should be located in the habitable zone. This is the sweet spot around a star where conditions are just right for liquid water to exist on the surface. Make sure your planet isn't too close or too far from its star. And don't forget about the temperatures. For example, you'll want a good amount of oxygen for a planet to be nice and warm, but not too much that everything spontaneously combusts. Of course, we need some water, but not too much, and a stable climate. You don't want your planet to be going through extreme swings in temperature or moisture. That's a recipe for extinction, not evolution. Oh, and the orbit should be stable, so that there are no major astronomical events that could throw things off. As you can see, this type of planet is very picky. No wonder it's so hard to find extraterrestrial life. Anyway, now that we've finished messing around in the Planet Creation Editor, how do we even build it? Well, how about terraforming? It's when we deliberately alter a planet's atmosphere, temperature, and other conditions to make it habitable for humans and other Earth-based life forms. For example, we could release greenhouse gases on Mars to warm up the planet and create a thicker atmosphere. But this method is more like polishing a monstrosity that was given to you by a character randomizer. What about building from scratch? That's something straight out of sci-fi. But maybe in the future, we could do that, using large-scale 3D printing or nanotechnology. We could create the basic structure and then add all the necessary conditions for life to exist. Of course, all this is still purely theoretical. But while creating a planet artificially is still a long way off, there are many creative ideas and concepts being explored by scientists and sci-fi writers. Who knows what the future might hold for the possibility of creating new worlds?
Imagine swimming in a salty ocean deep beneath the icy shell of a moon. There are geothermal vents around you, and they provide the energy tiny microbes need to survive. Or exploring a moon covered in rivers of methane and ethane, where life could be hiding in the depths of craters. The point is, we may not need to leave our own solar system to look for any sign of life outside of Earth. Icy moons could rewrite cosmic history with oceans sandwiched between an ice crust and a hot planetary core. Something unexpected happened in 2005. While visiting Saturn, the Cassini spacecraft flew through a fine water mist. It was spraying into space through cracks in the surface of Enceladus, one of Saturn's moons covered in ice. And the water was coming out at a crazy speed of 802 miles per hour. Cassini wasn't built to sample water, but it was still encouraging for scientists to discover something like that. They developed new missions where they wanted to focus on the icy moons of the outer regions of our solar system. On our home planet, water is the base for life, as we know it. And now, at least 6 moons might be spots where we could find watery oceans. 1 orbiting Neptune, 2 circling around Saturn, and 3 traveling around Jupiter. Scientists study extreme environments on our own planet to understand and guide their search for extraterrestrial life. For example, take such places as deep-sea volcanic vents and frozen lakes in Antarctica. They can tell us more about what conditions could support life on other planets. And these missions are led by a team of experts from different institutions that joined into something called Network for Ocean Worlds. They hope to finally find some life outside of Earth. Come on there, we need some new friends. So, hello there, Europa. Picture a frozen moon covered in double ridges that crisscross its surface like scars. Recently, scientists have discovered something exciting. There may be shallow pools of water on Europa, right under its icy surface. These ridges are very similar to those found on the Greenland ice sheet, and if they formed in a similar way to those in Greenland, these pockets of subsurface water may be common on Europa, hiding just beneath its frozen surface. Such pools form when subsurface water freezes and fractures the surface again and again, pushing up twin ridges. It's like when you put a can of soda in the freezer, and it explodes, pushing up the ridges on the surface. These ridges on Europa are up to 984 feet high and separated by valleys half a mile wide. And you know the rule, where there's water, there may be life. Chemicals that are necessary for life may be circulating from the icy shell down to the salty ocean far below the surface. And Europa has already been one of the most popular moons in our solar system when it comes to looking for extraterrestrial life, considering there's a deep ocean beneath its icy shell. Scientists believe this ocean could be 40 to 100 miles deep, which means it could hold twice as much water as all of our oceans combined. Another candidate is this tiny moon called Enceladus, which is about as wide as Arizona. Despite its small size, scientists think it could host some life, just like Europa. The reason? Again, a liquid water ocean and a thin layer of ice that covers it. In 2008, NASA's space probe, Cassini-Huygens, detected plumes of salty water vapor going out from the moon's south pole. Scientists analyzed the plumes and found organic molecules like carbon, nitrogen, and oxygen, which are important building blocks of life. Instead of a thick ice cap, like Europa has, Enceladus might have a thinner coating of ice mixed with crust. The plumes are really fast, which tells us they could be produced by a liquid ocean present at the moon's south pole. Scientists believe that on Enceladus, there's a constant process where water vapor rises up from the surface, then falls back down and turns into liquid water again. And it's been happening for hundreds of thousands of years. This movement could help distribute organic molecules that scientists think are necessary for life to exist. So, there's a chance for tiny living things crawling somewhere on Enceladus. Earth is a pretty awesome place, and there are a lot of factors that make it friendly to life as we know it. But when it comes to finding life beyond our planet, we can't just assume every other place in our solar system needs to have all these factors to have any signs of life. And one of the most promising places is definitely Ganymede, the largest moon in our solar system. It's gray and covered with craters, and it may look boring at first glance, but don't let its dull appearance fool you. We've recently discovered there's water vapor in its atmosphere, and there's more to it than just water. On Earth, we have a lot of other fun and useful factors that make it a good place for life. We have a magnetic field that protects us from harmful radiation, and a big moon that creates tides that help mix up our oceans. We also have a deep liquid water ocean and land masses with different elevations that create a variety of environments for life to thrive. Ganymede has some of these factors as well. A magnetic field check. Plus, it's Jupiter's biggest moon, so tidal forces are present there too. Ganymede is tidally locked to Jupiter, which means it always shows the same face to the gas giant. But even though it's so close to Jupiter, Ganymede still manages to rotate around its own axis every 7 days. A magnetic field and strong tidal forces are factors that could help create and maintain a liquid water ocean deep beneath the moon's icy surface. And this ocean may not be just for potential galactic vacations. It may also harbor life. Let's head to Io, the third largest Jupiter's moon. We're talking about a very special place since it's the most volcanically active body in our solar system. Yep, there are more than 400 active volcanoes that shoot out gas and other stuff there. This helped with creating a thin gas atmosphere, mostly made of sulfur dioxide with traces of oxygen. Volcanoes also make certain parts of Io really hot as 3,000 degrees Fahrenheit. Some other areas are very, very cold, minus 202 degrees Fahrenheit. Life could hardly develop in such extreme conditions. Plus, Io doesn't have water or organic chemicals, and it orbits within a ring of dangerous radiation. But scientists believe there might have been life on Io a long time ago, maybe even in some other form that we don't know about today. It could still be there, deep under the moon's surface. Some simulations suggest that Io formed in an area with lots of liquid water, which combined with its heat could have fostered life. But any life on the surface would have been destroyed by the radiation after only 10 million years of existence. So, if there's life on Io, it's probably deep underground, safe from all the crazy radiation at the surface, like people building entire cities in all those apocalyptic movies, hiding from whatever's out there on the surface. So to check that out, we'd need to send a special probe to find it. But building a probe that could land on Io and drill deep enough to find life is a very big challenge, and we're not quite there yet. Mars is a planet that scientists have studied a lot. They believe the red planet used to have liquid water and freshwater lakes on its surface. It's way better than what we have at the moment, just some plain ice caps on Mars' poles. But there could be some organic compounds present in its crust. These days Mars is extremely cold and has a thin atmosphere. Not very promising. But some scientists think the red planet used to be much warmer and more hospitable. Hopefully all those rovers and probes will bring us some awesome news and evidence of life.
Scientists keep finding new planets they call super-Earths. It's a class of more massive planets than Earth, but way lighter than ice giants, such as Uranus and Neptune. Super-Earths can be made of rock, gas, or a combination of these two. They are often twice or even up to 10 times bigger than the Earth. They're interesting to study, but kinda too far away from us. They're pretty common outside of our solar system, together with other interesting planets like mini Neptunes. Those can also be gas dwarfs, ice giants, or huge rocky bodies. But again, we don't have anything like that. But something we do have that those other solar systems don't? Jupiter. It's the biggest and heaviest object that orbits our sun. This king of planets possesses a powerful force to dominate our solar system. Jupiter is notorious for eating planets. A protoplanet slammed into it about 4.5 billion years ago, when Jupiter was still a young planet in its early stages. This protoplanet was 10 times heavier than Earth and was made of ice and rock. The collision was huge. Jupiter's core broke apart, and helium and hydrogen mixed with denser materials. Through time, the heavy material settled back into the dense core, which is what we see today. And if it swallowed a planet before, it might keep doing it as well. We suspect our solar system used to have many more large planets than it has now. For example, it's kinda empty around Mercury today. Similar areas around many other central stars are definitely more packed with intermediate mass planets, with the size between Earth and Neptune. Our solar system was a chaotic place at its beginnings. Young stars were surrounded by swirling disks of dust and gas, and planets would form out of that debris, something like trees when they're springing up from the ground. Small rocky planets would form in the strong heat and light close to stars, while gas giants would form farther out, where temperatures were lower, which means they could preserve more gassy materials. And even though planets in our solar system seem pretty stable and peaceful today, following their orbit, they weren't that calm before. Some planets didn't have a circular orbit. They had oblong, more eccentric paths. It took them swinging first toward their stars and then farther away. It was like they had been thrown off kilter by the gravity of other planets on their way. There's something called the grand tack theory. It explains things happening in the first few million years when our solar system was forming. At some point, Jupiter, one of the key players here, may have been pulled in closer by our central star. After that, it went back and took a huge cloud of debris. It was like a sailboat when it tacks around a buoy. This kind of messed with planets that were in the process of formation. After Saturn was fully formed, our close neighbors in the solar system cleared out a little. But if the idea about grand tack is correct, Jupiter had grabbed everything in its way, and its migrations had caused more collisions in this area. Jupiter might have delivered some of the water that now fills the oceans we have on our planet. It shepherds plenty of asteroids. From time to time, it sends some whizzing into interstellar space, or amongst the planets in our solar system. It may have even taken part in the dinosaur extinction 66 million years ago. When the huge space rock hit the Earth, it left a crater off the coast of the Yucatan Peninsula in Mexico. It all caused earthquakes, volcanic eruptions, and tsunamis that made a huge impact on all animal and plant life on Earth. No one knows where it came from. We're not even sure if it was an asteroid or a comet. One theory says it may have been a comet that came from the Oort cloud, which is made of icy debris and is located somewhere at the edge of our solar system. It could have been bumped off course by Jupiter and its powerful gravitational force. This way, our solar system was like a pinball machine, where Jupiter, the biggest planet, kicks incoming comets into orbits that send them closer to the Sun. When these comets are near the Sun, they can go through strong tidal forces that break them apart and eventually create shrapnel-like pieces of a comet. That event was a point when our mammalian ancestors started to rule. That means without Jupiter, there might not be us either, nor the Earth. It seemed like our biggest planet came swinging in, destroyed older planets, and cleared the way for smaller worlds like ours. Jupiter may have been the reason why we can't find Planet 9 right now. Scientists believe it exists, and they think it could be hiding somewhere beyond Neptune, but not Pluto. There are 3 zones in our solar system: the inner planets, outer planets, and whatever there is beyond. The mysterious planet could be the size of the Earth or Mars. It swirled among the gas giants before they eventually swept it toward the outer parts of our solar system, or even somewhere into deep space. Jupiter has stripes because of differences in temperature, atmospheric gas, and chemical composition. Scientists used to think the only reason for these different colors was the mighty atmospheric wind and material circulating between layers of the atmosphere. Now we know the light-colored stripes, or so-called zones, show us where the gas rises. When the stripes are dark-colored, they're called belts and can tell us where gas is sinking. Jupiter's moons could also be why the planet is stripy, because they're tugging on its atmospheric convection cells. At the center of Jupiter, there's a dense liquid core made of helium and metallic hydrogen, together with dissolved heavier elements. As we go further from its center, the temperature and pressure inside the planet drop off. That way, the liquid interior gives way to gases from the atmosphere. Again, mostly helium and hydrogen. No one knows how deep this liquid-gas boundary lies, but the planet is probably fully liquid a couple of thousand miles under its cloud tops. Jupiter would still be bigger than some other giants, like Saturn, if we could strip its gases. Jupiter is sometimes even called a failed star, although that's not quite correct. It's mostly made of hydrogen, like regular stars, but it's still not massive enough to start thermonuclear reactions in its core, which would eventually turn it into a real star. In theory, every object could be turned into a star if you only add enough matter to it. If there's enough mass, the temperature and internal pressure will increase and start thermonuclear reactions. So, to turn Jupiter into a star, such as the Sun, you'd have to make it 1,000 times more massive. But to form a cooler red dwarf, you'd only need 80 Jupiter masses more. That way, Jupiter won't spontaneously become a new star of our solar system. But if many space objects with similar mass collide with it, or in other words, if Jupiter eats them, then maybe. You never know. But in theory, if it could become a massive star, it would have stopped other planets from forming in stable orbits. It would have also increased the radiation that the surface of those planets get, which is why it would be really hard for life to develop in our solar system. Jupiter is the planet that spins the fastest in our solar system. It only needs 10 hours to make a full rotation on its axis, even though it's huge, more than 300 times bigger than the Earth, and 2.5 times more massive than the rest of the planets in our entire solar system together. But if it got more massive, it would shrink. More mass would make Jupiter denser, which means it would begin pulling in on itself. So it could get 4 times its mass and would still be the same size.